Basic communication principles. In this film, we will cover the definition of communication, and later films will cover some communication basics. First of all, let's define communication. Communication, if we draw a circle like this and call this communication, pardon my handwriting, but let's say that this circle covers everything that has to do with communication. Communication is defined as making yourself understood. So if I communicate to you, you get a sense of what I'm speaking about, you understand what I'm talking about. But if I were to talk to you in Chinese, you wouldn't understand it, and that wouldn't be communication. So therefore, when I communicate to one, or when I communicate to many, that is communication. Sometimes the communication requires a reply, and sometimes it gives a reply, but still, if I communicate to you and don't get a reply, as long as you understand it, it's communication. And I can communicate by voice like I do, or computers, or maybe smoke signals, or light signals, or something like that. So in this communication circle, we have something called telecommunication. And telecommunication is communication by using aids. So you use something to help you with the communication. And there are two reasons to get help. And one is to increase the distance, hence the name tele, which means far away in Latin. And the second would be to increase the speed, to get faster communication, to communicate more during a shorter time. So you can say that when you communicate by computers, for example, sending a text message or something, that is telecommunication because you send a text message maybe across the country. But also smoke signals and light signals are telecommunication. So inside here we have something called data communication. So in the communication ring it's larger, telecommunication is smaller, which means that we have some kinds of communication that is not telecommunication, and of course we have some kinds of data communication that is not telecom. But data communication is digital. So that is when computers communicate with each other. And of course my cell phone is a computer. So computer communication is data communication. And then finally, this last circle in this diagram is the industrial data communication. Of course, we have data communication that is not industrial. For example, the communication that you will find in an office, where you maybe use your internet, your mail, or something like that. But in industrial communication, you use data communication to make devices communicate. And in the industry, you have things like harsh environments, which you do not have in an office landscape. You also have the absolute requirement of reliability. In an office landscape, if I lose my data for half a minute, well, okay, it's annoying, but it's not critical. But if you lose your communication in, for example, a nuclear power plant, that's really critical. So you would really like to have definitely the most stable data communication is for industrial purposes. So therefore the communication onion, because it has all these layers outside each other. The timeline of industrial communication, post-war era, you had pneumatic communication. So for example, a temperature transducer would have temperature on the x-axis and pressure on the y-axis. Now, of course, it's much more convenient to have electrical communication, so current or maybe voltage on the y-axis. So when transistors started to become common, analog signaling took over for the pneumatics, because the pneumatics require pipes and the analog requires wires, which is much more convenient. Then in the 1980s, computers started to become common, so they created a hybrid between the analog signaling and digital. So there was on the one cable, cable could cover both. For example, this one could be the temperature, and the digital data could be, for example, which transducer sent the data. So you could have, on one line, you could have multiple transducers, each of them sending current, but also telling who they were. So therefore, you could say, okay, the temperature at point A is that, at point B it's another temperature, at point C it's a third temperature, and so on. Now, of course, in the 1990s, field buses took over, which are 100% digital, because the digital signaling or data communication became faster. Now, also at the same time, mid-90s, the internet became very common. I had my first email address in 1993, for example, but the internet protocols or the internet way of talking wasn't considered very reliable. So therefore they had special communication methods called field buses, which were reliable, and it wasn't until, say, 2010 that the Ethernet protocols became reliable enough for use in industrial applications. But as you see on this timeline, actually all these bars could extend a bit further. Even though pneumatics have become quite rare, they still exist. The fully analog signaling still exists very much in the industry, and so does these hybrid ones. But for new plants or for new equipment, this is the major communication method between industrial devices. For an office network, you basically have one so-called protocol. A protocol is a set of rules on how the communication should take place. So in an office network, you have TCP/IP, which is the LAN protocol. So every computer you buy is able to communicate via TCP/IP. And that could be either wireless TCP/IP, so-called VLAN, or wireless LAN, or it could be cabled LAN or cabled TCP/IP. So the set of rules in an office network is basically TCP/IP. While in the industry you have a large selection of communication protocols. So, for example, Profibus is one, Modbus is one. Some are proprietary, which means that they belong to that specific industry brand. You have others here, like the Heart that was shown on last slide and so on. So you basically have a large selection of standards. Some are popular in the United States. Some are popular in Europe. Some are popular in Asia. Some are popular within electrical power plants. Some are popular in the car manufacturing industry, and so on and so on. So you have a large selection. While I would like to say, thank Lord, that we only have one standard in office networks. And so when the Ethernet-based protocols, that is the internet protocols, became popular in the industry, we see the great number of different protocols here as well. But they all communicate basically in the internet way of doing it, but the messages that can be sent are a bit different.